Welcome to another class on system programming. We have been discussing about macros for a while. So we saw what do you mean by a macro call and what do you mean by a macro expansion. So today we are going to discuss about what are the different data structures used in a macro, used by a microprocessor. So what are the different data structures that has been used? Right, before going into it, let me again elaborate on what is the work of the macroprocessor. So the work of the macroprocessor is to recognize the macro definition, save the definition, recognize the macro call, expand all the macro calls and substitute arguments. So this is going to be the work of the macro. So what is this? Before explaining you what this is, I will tell you what is the work of the programmer. Programmer will write a macro. Right? So programmer will write a macro. It will start with the keyword macro and end with the keyword emend. So the macro will have a macro name followed by arguments. Right? This is how a macro is going to be written. There will be a start with a macro name with followed by arguments, and the next few lines will be the code or your instruction, which is going to be your macro definition. Right? So what is the work of the macroprocessor now is the programmer has written a macro in this particular format, and the work of the macroprocessor is to first recognize if there is a macro definition. Okay, so macros usually are written before the main program, right? So it has to first search for the keyword macro. If it finds a keyword macro, which means it has found a macro definition. Whenever it finds a keyword macro, it will assume that it has found the macro definition. The next line of the macro keyword will be your name of the macro, will be the name of your macro. So what is the work of this macroprocessor is, it will search for the keyword macro. The next line of it will contain the macro name. So it is going to store the macro name in a separate place. Okay, it's going to store it in a form of a table. So it is going to store the macro in form of a table. So there are two different tables. One is called as macro name table, okay, where the macro names are stored, and there is another table called macro definition table, where the definition of that particular macro is stored. Okay, this is the work of your macroprocessor. First it goes and recognizes a macro definition, stores the name in the macro name table, and it is going to store the definition of that particular macro in the macro definition table. So these are some two of the data structures which we need. Right? So what it has done, it has saved the definition. Then after it is saved, when the actual macro call happens in your main program, it has to find out which macro is being called. Okay, by seeing the name of the macro, it will recognize that this particular macro is called. So what it will do, it will substitute the macro definition from the macro definition table with wherever the call is there, wherever the macro call is there, it is going to substitute it with macro definition. So we have seen it, these things, we know all these things happen, but now that we know what data structures it is going to use to do this, okay, it will find the macro call and it is going to replace it with the definition. You understand? So let us see what is the process, what happens. In the last point, you see that expand calls till that we know, and substitute arguments. So you know that what you mean by substitute arguments is you have these actual arguments and then dummy arguments. So you have to substitute it. So you know that part also. So how these things are done, what databases are used for doing all this process is what we are going to discuss today. Right? Let us move on to the actual topic. Here, so whatever is colored here, are the databases I wanted to talk about. The first database I'm going to talk to you is about, it's called as macro definition table, MDT. Right? So these are also 2-mark questions, or there can be a 5-mark question which is going to talk about or ask you to explain the databases used in pass 1 and pass 2 of the microprocessor. Right? The first data structure here is called as macro definition table, MDT. What it does, of course, as the name indicates, it stores the macro definition. Right? So there is another, go to the point number 5, macro name table, MNT. So first two tables which you're supposed to remember is macro name table and macro definition table. Macro name table will only store the macro names. Okay, macro definition table will store that particular macro, which means the instructions. Right? It is going to store. What is the format? Once we see the structure of those tables, you will know what is the format of macro name table and macro definition table. Right? So like, as you know that there is MDT, macro name table, there is also another data structure here. It is nothing but macro definition table counter. Right? So this structure is going to be like a counter, like a variable. So MDT table is like a table structure, whereas this data structure is going to be just a variable which is going to keep the count of all the definitions. So every time you enter one line of code, so that will be counted. So who does that? Macro definition table counter is a variable which is going to count the macro definitions present in the macro definition table. Similarly, there is another counter called macro name table counter. So you know that there is a macro name table, it stores all the macro names. There is also a counter which counts the macro names. Right? This is called as macro name table counter. So this is another data structure. This is going to be kind of a variable. Right? The last data structure is nothing but argument list array. So what is this? So these things at least, yeah, we can relate to it. We know that all these things are going to be stored in form of a table, macro names and macro definitions. What is ALA? ALA is a very important question. So listen carefully. Argument list array. What do you mean by argument list array is we have seen that arguments can be used in your macro definition. Right? We saw that there will be arguments used in your macro definitions. Right? So what is this is? There is a table called argument list array inside which all the arguments will be given an index, given a value. Right? Say for example, the first argument you come across will be given as #1. Hash is a symbol used to define the index of an argument. Right? So because macroprocessor is using hash, programmers are not supposed to use hash in the program. So hash here is for the use of the macroprocessor. It is going to give an index, give a number for all the arguments present. Right? And it is going to have a table wherein it is going to have all the arguments. So it doesn't matter if it is going to be when a macro call you give a dummy argument and it has to substitute the actual argument. The confusion is reduced how? By using this index. So this index will take care of that substituting. You understand? So let us see each table in detail. So what are the tables you should remember? Macro name table counter. Macro definition table counter. And you should know what is an argument list array. ALA argument list array. As it says, it is like a form of an array. Right. So let us see one by one. Okay, so whatever we saw in the previous slide, so again I go back to that slide, whatever we saw, it's all these things happens during pass 1. Okay, so the work of the macroprocessor is to find the macro definition and then substitute it with the definition, find the macro call, substitute with the definition and expand it. Right. To do this process, it actually takes 2 steps. One step is to call the pass 1. Okay, half of the work is done in pass 1, the other half is going to be done in pass 2. Right. First, it will find the macros names, it will store them in macro name tables or find the definitions, so store them in the macro definition table. So these things, all the arguments will be taken and stored in the argument list array. This part is done during pass 1. During pass 2, what happens? It has to expand the code. Expansion of the code is what happens in pass 2. Right? So what it needs is that time, instead of having a macro definition table counter, instead of having macro definition table counter, it has another data structure called as macro definition table pointer. Okay, the name only is different, but the work it is going to point to the definitions one line after the other. Each line you are going to read, each line of the definition is going to be read using this particular pointer called macro definition table pointer. It is one and the same. So when it is used in pass 1 to storing the definition, it becomes macro definition table counter. When it is reading the definition and it is going to expand the code, it becomes macro definition table pointer. You understand? So only thing is, this is the concept behind all these databases. Only thing is we have to see the structure of these databases. That's it. If you see the structure, that's it. We are done with this class. Right. First, so this is macro definition table. Okay, so the macroprocessor's work is like this. So what is the work of the macroprocessor is, first of all, it should find where a macro is defined. How will it find it? It will search for a keyword called macro. The next line will be how it is defining a macro, right? So starting from the next line, it will not store the keyword macro. The macroprocessor will find whether there is a keyword called macro. Once it finds a keyword macro, then it knows that the next line is going to be the definition. So it copies the lines from the definition, which means INCR, for example, is your macro. So it's going to start copying the code from there till mend. It also copies mend. Why? Because in your macro definition table, you should know that this macro has ended. Okay, so that the next macro will start. Otherwise, there will be confusion of code. Where it starts and ends, you will not know. Right? So macro keyword is left out. So that is the structure here. Right? That is structure we are following here. So we are leaving the macro keyword, and from the next line where the actual macro name is there, no, from that line we are going to copy and paste it inside which table? Macro definition table. Till mn we are going to enter, given not copy paste, it's like you are going to enter all the values whichever is present in your macro into this particular table, right? Yes, so this is going to be the table. See the structure of the table, right? It has index. So what do you mean by index? It's like a line number. So we assume that there is already an entry. Let us assume that there is an entry. It has occupied 14 values, 14 line numbers. Line number 15 is nothing but this new macro, right? That's what we are going to assume here. So this example, we are assuming that at line till 14 it is occupied, the table is full, macro definition table is full. From line number 15, now we are going to write our definition. Our macro, INCR is our macro, that definition is going to be filled here. From 15, we are going to fill it till 90. Right? This is all is going to be the contents of your macro definition table. Right? It goes on. So this count, this index will tell you how many lines of macros are there in your particular program. In your one particular program, how many lines of macros are there? This is going to be known to you by your macro definition table counter. So which is going to have a count of the number of lines. Right? Yes. The next one we are going to see is macro name table. See, first thing table which is going to be filled here is going to be the macro name table, because first of all it will see where is a macro. Once it sees the keyword macro, first thing it is going to see is what is the name of the macro. As soon as it finds that the name of the macro is INCR, so it is going to enter it in the macro name table. But what will the microprocessor not know is, it will not know what is the index of macro definition table, which is 15 here. Okay, until it stores some values inside the macro definition table, it will not know what is this value. What is this value? This value is nothing but it comes from here. Okay. So I know I'm saying in the macro definition table, the name of my macro is INCR. Okay, where is this definition stored? Only the name is going to be stored in name table. Okay, where is the definition stored? It's like a pointer. You have to go to macro definition table and see index number 15. That is where my definition of this INCR macro will be present. You understand? So that is your that is the relationship between your macro name table and your macro definition table. Right? This is macro definition table. This is your macro name table. As you already know, we assume that in this program there are already two macros written. This is the third macro. Right? It only contains the macro names, which means macro name table will only tell you how many macros are there in your program. If you see the whole table, you will get an idea of how many macros are actually defined in the whole table. Right? So the index is here 3. So we are not going to use this index for any other purpose. Just you are going to make an entry. It's just a pointer. Right? So what happens now? Macro name table counter is nothing but will be 3. Next time if it is going to encounter another keyword macro, then it will start writing that macro name here in where the index is 4. So it will increment the macro name table counter, which is MNTC, and there it is going to fill it up with the macro name. And the respective macro definition will go into the macro definition table. Hope you understand. So this is the two things which happens. So if you are able to explain what happens with these tables, data structures itself, in a way you are also explaining pass 1 and pass 2. Right? This is what is happening. So you know, when you explain about MDT and MNT, MDTC and MNTC, you are explaining complete pass 1 is explained there. And ALA, of course, and ALA also. All this when you explain means you are explained pass 1. Pass 2 will only want to expand it. Find the call and expand it. You understand? Right. So that is what happens in pass 1 and pass 2. So I'm trying to relate these databases to your pass 1 and pass 2. So we will also see where it is used. Okay. So I told you there are these two tables, important tables, which is MNT, MNDT, and there are two pointers MNTC and MDTC. So we have discussed about all that. The next very important 2-mark question, you can see this question in many question papers. It's nothing but argument list array, right? It is very, very simple concept, right? So what is the use of argument list array is dummy arguments are replaced with positional indicators, which means wherever there is argument, say argument 1, comma, argument 2, comma, argument 3 is there, right? So those things will be replaced with #1, #2 and #3. And you will know correspondingly which is the actual parameter also. You will also be knowing what is the actual parameter. As I told you, this hash symbol is used only by the microprocessor, and the other programming in your program you are not supposed to use the hash symbol. It is meant for microprocessor only. Let us see one example so that you understand. Let us say here in your macro name table, we saw the macro name table, if you remember. Actually in our macro name table which we saw before, it was actually a1 comma argument 1, right? But here actually what happens is the microprocessor would have renamed all the arguments. In order to avoid confusion between the actual arguments and the dummy arguments, the arguments are given a tag. Okay, so it is going to say #1 means the first argument, #2 is the second argument. Say for example, your actual parameter will be A, B, C, D, your dummy parameter is going to be X, Y, Z. So you have to say which is X, which is A is equal to X and all. So instead of doing all that, we just name it as #1, #2, #3. So why it is saying positional? Because here #1 is the first position parameter argument, #2 is the second parameter, which is the second argument, #3 means the third parameter. So corresponding to the position of the macro call, this particular ALA will be maintaining a table. So what table it is maintaining, we will see. This is not the ALA, this is just a macro definition table wherein we have changed the arguments. Let us go see how the ALA looks like. This is how ALA looks like, argument list array, right? So we are going to only start, let us assume that these are the first, this is the first macro which has these arguments. So this table is going to start with 0, index 0. First argument here is loop 1. So if you see, sometimes in INCR, not argument 1, 2, 3, instead of that we also would be having a label. In one of the examples we have seen that. So it will be like ampersand label, then INCR argument 1, 2 and 3. So in that is the case, then the first argument is nothing but it's going to have the index. So what do you mean by #0? #0, if I have, say for example, if I have #0 in macro name table, okay, so what should be here in the argument list array? Argument list array should say, what is that #0? #0 is nothing but loop. Okay, so this is going to be represented using 8 digits, 8 characters. So if I have LOOP1, so it occupies 5, and these 3 are going to be last 3 bits. So you are going to say, I am going to have the size, I am going to give the name is going to be 8. So I should be having 8 characters, right? So 0 here represents loop 1. 1 here, #1 in my macro definition table, #1 in my macro definition table, it means nothing but it means it is argument 1. #2 is nothing but it means argument 2. Instead of using argument 2 directly, I am giving #1, 2 and 3. 0 here, it's representing that particular label. You understand? So if this is the entry in the macro definition table, the corresponding entry in the argument list array will be like this. Okay, it will tell you what you mean by 0, what you mean by 1, what you mean by 2 and what you mean by 3. Yes, so though I say when I am defining, I will give the argument, but what is the passing parameter here? The passing parameters are going to be data 1, data 2 and data 3. So your code should be replaced by A1 comma data 1, A2 comma data 2, A3 comma data 3. Yes, so this, you know, the examples we have seen, the same example. See, throughout microprocessor, we are sticking to the same example because you will not have any confusion. We don't want to confuse you with other examples. With the same example, we are going to only discuss the cases, different various cases, right? So this is one of the data structure which is going to used in pass 1 and pass 2. It is nothing but argument list array, ALA, right? Yes. So what data structures we have discussed so far? MNT, MNTC, MDT, MDTC, ALA. Yes, right? Let me show you where these things are used in your pass 1 and pass 2. Say here. So this is going to be your pass 1 of macroprocessor. So whatever we said, the same thing is there in form of a flowchart. So you have MDTC is initialized to 1, MNTC is initialized to 1. So you know what that is. MDTC is nothing but macro definition table counter, macro name table counter. So this is the thing we are initializing and using it. So what we do is every time we go find a macro, we will increment the macro name counter. So whenever you find a macro, what you do, you are going to increment the macro name table. You are going to increment the counter by 1. You will store the name, and then in the macro definition table you have to keep incrementing until you finish the code. So when how long do you have to do it? You have to keep incrementing until you find mn. Once you find mn is found, which means your definition is ended. So macro definition table counter will not increment. Then when you find another macro, then the macro name table counter will increment. Then again you will start incrementing the macro definition table until you see mn. Okay, this is what happens in pass 1. Pass 1, it is going to first recognize macro keyword, and then it is going to store it inside a macro name and definition tables. That's all happens. Expansion happens when? Expansion happens in pass 2. So in pass 2, what it does, it will go to the macro definition table, read the pointer values one by one. Line by line it will read, and it has to expand the source. You understand? This is the work of your microprocessor. So that's it for in this class. Thank you.